So for today's session, we will cover on the 5.3, which is we are still at the 5.3 discussions about cabinet, which is more to the fabrication process. Before that, we have discussed about 5.2, which is also related to the cabinet, but that one was related to design process of the cabinet. Now, we are still in the section 5.3, which is the fabrication process of the cabinet. All right. So I will continue from this slide where we have finished this up to previous slides last week. So from this week, from this session, I will begin from this slide. All right. So basically, we have been talking about finishing up of our sheet metal, right? So we can use the files here to do the finishing of our sheet metal. And after that, we will begin forming the sheet metal, which is we are going to form the sheet metal into the desired shape of the cabinet that we want. All right. So for the cabinet, before we shape this sheet metal to form a cabinet, basically we use this sort of machine, which is not an automatic machine, but it is more to the manual machine called the bending brake. Okay, so we use this sort of machine, the bending brake, to do the forming, to do how we can form a shape of our sheet metal. Okay, so what is the elements or the parts of the bending brake? Basically has some several parts, which is the work table. So the work table is the table that we are going to place to put on our sheet metal. And then we have the metal fingers. Okay, so this is the metal fingers. The top part is the metal fingers. All right, we can lift up the metal fingers to place our sheet metal here. And then another part is the bending wing. All right, so there are three parts, which is the first one is work table, and then metal fingers, and another part is called the bending wing. All right, so this is the fingers, and we place our sheet metal on the table, and then there is a bending wing where we can use that bending wing to shape, to make shape of our sheet metal. Okay, so basically this is another figures that shows the bending brake. As you can see, this is the bending brake fingers. Right, we can place this sheet metal in between the bending brake fingers and also the table. There will be another figure, which is this one is much more clear figure that you can see. There are some parts of the bending brake here. All right, based on these figures, there are 5 steps of bending sequences. When we do the bending of our sheet metal to form a cabinet, basically we'll need to follow these 5 steps, which is the first step is basically what we do is we raise up this finger. Okay, we push this finger back. All right, so that it will open. So this finger will open some space between fingers and work table, so that we can place our sheet metal. All right, so this is our sheet metal, which is our sample to be bent. So we place this, and then after that we pull this clamping handle, which is we move forward this clamping handle to press it. To press firmly and evenly the sheet metal. All right, so to make it firm before we do the bending. So next step, which is the third step, is we hold this bending wing. Okay, we hold this bending wing and we raise up into some angle that we want. Okay, so we bend this sheet metal using the bending wing. and then we bend it into the desired angle, and then finally, for example, if you want the right angle, which is 90 degree of this sheet metal, okay, so we'll do it like this. And after that, to release this sample or our sheet metal, we again we push this clamping handle back so that we can release our sheet metal. So this is the sheet metal that has been bent. Okay, so next step, after we bend our project or our cabinet into the form, the shape that we desire, okay, the shape that we require, then what we do is to finishing up by using painting, for example, and also we can use self-adhesive vinyl, which is something like this, which is we normally call this one as a sticker, right? Plastic sticker or paper sticker. Okay, so this is in this case we call this one as adhesive vinyl coating, and we can also use aerosol spray like this to paint our cabinet. Okay, to do the spray painting of the cabinet, what we supposed to do normally, firstly, what we need to do is to prepare the surface, okay? To prepare the surface to make sure that the paint stick very well, okay? So to prepare the surface, basically what we do is to clean the metal surface. The metal surface, which is our sheet metal or a cabinet that we have already formed into our sheet metal that has been formed into the cabinet. We remove all of the dirts, grease, like something that is you feels like oily, something like that, to make sure that the surface is clean enough before we apply some paint on it. Okay, so before we do the painting, even though we are using this sort of spray painting or aerosol painting, what we need to do first is to apply the primer. Okay, so this primer is basically it is also the aerosol paint that is used to seal and fill the metal, meaning that we apply primer. It's like a sticky something that is to make the surface, which is to make sure that the surface is ready to be painted using the colored one. All right, so the primer is actually belongs to the surface preparation as well before we do the painting using the colored aerosol. All right, so basically when we choose the primer, normally we can use this type of primer, which is a zinc chromate based primer, which is the most suitable one. All right, and then after we apply the primer on the surface that we're going to paint, then we can do the painting based on the color that we want. For example, the red one here. So we apply the painting using the spray paint like this. So this is what we call as enamel paint, which is also available in aerosol can. Okay. And then when we choose the paint, sometimes we will need something that is semi-gloss or less glossy, right? Okay. All right. So next is other than using painting, which is the spray painting or aerosol painting, we can do the finishing in terms of using the self-adhesive vinyl, right? So this is this self-adhesive vinyl, which is like a normal sticker, which is something like this, the plastic sticker. All right. So we can apply this self-adhesive vinyl to cover up our cabinet. Okay. It is a contact paper that comes in variety of painted patterns. Right? Some colors, green, yellow, blue. right? Some shapes, some like something like wood grain, right? So we apply it correctly. It provides durable surface for professional look to any cabinet. And then using this self-adhesive vinyl is something like easy to use. Okay, we just can cut it into the appropriate size and then apply it. So it's not like painting. Painting needs some sort of skill as well. But for this self-adhesive vinyl is something like straightforward. We can just cut it, apply it, and make sure that before we apply it, we have to make sure that our surface is clean enough before we apply, right? Okay, and then after we finish covering up our cabinet, whether using the the paint-based spray or the vinyl, self-adhesive vinyl. So basically what we do is to do the labeling, okay? The labeling process is basically to make it literate, meaning that, for example, we want to label some wires, some components like switch, supply switch, some ports, connectors, for example. So we are going to make sure that we know that, for example, that is ground wire, that is 5-volt wire, okay? That is the switch, right? So we are going to label it to make sure that when the intended person use it, they know, okay, how to use it, right? So basically, when we do the surface labeling, there are two options, whether to use the dry transfer lettering, which is something that you can have a look in this figure. This is an example of the dry transfer lettering, and also Dynamite imaging system. So there are two options, which is dry transfer and also Dynamite. Dynamite is much more some things like the machine that we can use for imaging system, right? It's not a printing machine, but it is much more like something that we can do, like we are producing the photo, for example, we do the exposure, include the exposure into UV lights, right? Which is much more proper labeling based system, right? Okay, so for dry transfer lettering, so it does not only consist of letters but also numbers, okay, and also some graphical symbols, right? So it has some variety in terms of size and also styles, okay. So basically we can go to the stationery stores to find this sort of dry transfer lettering, something like this, okay. And this sort of method, which is using dry transfer lettering, it is inexpensive, and it contains letters, words, phrases, numbers, and many more, so that you can do the lettering to your or labeling to your project. Okay. So in addition to, you need to, okay. So in addition to the lettering sheet, which is this one, this is the lettering sheet, you also need some other tools like burnishing tool, right? Burnishing tools, masking tape, graph paper, and also kind of clear protective spray. All right. So basically, all of those tools will be used in the dry transfer lettering process. For example, this is the step that can be taken to apply the dry lettering. Okay. For example, in the first step, you need to lay out design on the paper, right? Then use masking tape as a guide. So we can use the masking tape. the normal masking tape as a guide before we apply the dry lettering. Then position, transfer shade, and rub on with burnishing tools. Burnishing tools is the tool which we can use for the surface preparation before we apply the dry transfer lettering. And then number 4 is remove unwanted lettering with plastic tape. Any unwanted lettering, we just remove it. And then number 5, apply index marks carefully. So we apply this carefully. Then after we finish applying all of the marks or the labels, then what we do is to use some protective coating like silicone spray or clear spray. Okay, basically when we do this sort of lettering, we should cover it up by using clear spray. Okay, not white but transparent spray to make a protective film to protect to make our lettering or our labeling long lasting. And then the Dynamite imaging system, which is the second option, we can choose to label our cabinet or our circuits, wiring, and so on. So basically for this Dynamite imaging system, basically it has a video, a short video that I think I can just show you. We still have time. We don't have much time, so better not to do it. Okay, so Dynamite imaging system, which is something like this. We can do the design, okay, create a film first. Then after that, we print out, right? From this design, we print out. Let me just laser pointer. So after we design it and we print out, and then we print it onto the film, which is plastic film like this. And then we use this plastic film to apply to the sticky paper or the paper that we are going to transfer this mark. All right. So after that, we do the exposure to the UV light. Okay. Once we do the exposure to the UV light, and then we put some water and then just rub it with the tissue paper, for example, with the cloth, and then it will appear something like this, which is the finish label. For example, all of this label is made from the Dynamite based imaging system. All right. So next, after you finish the fabrication process of the cabinet, the next step, which is in this section 5.4, I'll be talking about the finishing process. All right. So in this finishing process, this is basically when we have done with the cabinet, forming the cabinet, and then paint it, and then after that do the labeling. Okay. This step is basically to complete the wiring process, which is we will do the wiring plans and also final packaging, which is basically in terms of wiring here, I'm talking about the wiring that is outside from the PCB board. All right. So we have discussed before about the wiring procedure, which is also we have discussed about the wiring diagram, right? So based on that wiring diagram, basically we will do the wiring of the components of the PCB to the other components outside of the PCB. So basically, when we talk about wire, there are two types of wire, which is the first one is the multi-strand, and the other one is the single strand. So wire could be single strand or multi-strand. Okay, two types of wire. There are pros and cons between these two types of wire. For example, a single strand wire, it is single strand wire like this. So there is only one copper wire. Okay, inside this insulation, this is the single strand wire. The multi-strand wire could be some multiple copper wires like this, some 7 core, some more than 10 cores, for example. So this is the type of multi-strand wire. So basically, for the wire, the most suitable size of the wires that can be used for electronic project is for example, in this case, we normally use number 22 size or number 24. Okay, this sizing of wire is basically we can use this sort of gauge or tools to measure the diameter, which is the size of the wire. Most of the wire at this size, in number 22 to 24, can withstand the current up to 20 amperes. So that it is more than enough for the small prototype project or electronic project. Okay, so normally in electronics project, we use number 22 to number 24 gauge or size of the wire. For example, as you can see in this sizing standard, British standard of the wire size here, it starts from as big as 0.5 inch. 0.5 is about the size of my finger. All right. So about the size of my finger of the wire, and to the smallest in this table, as you can see, to the smallest size. Basically, for the 22 size, number 22, it is about 0.028 inch or 0.77 millimeters in diameter, right? And then that was about the sizing of the wire and then types of the wire. Now, when we have the wire, what we do next is to do the wire splicing. Okay, wire splicing is basically the method how we connect two wires. All right. So there are three types of wire splicing, as you can see in this figure. The first one is red tail. Let me just delete this first. The first type of wire splicing is called the red tail. All right. So the red tail type wire splicing is something like this, as you can see in the figure, which connect two wires, which is like this, right? So we have two wires. We just twist this into this sort of connection. And then the second one is T splicing, which is something that looks like this, T shape, letter T. This is the T splicing. As you can see, we can have a wire, one wire here and the other wire. Okay, the other wire open, then we just do the splicing like this. Okay, so this is T shape, which is we call it as T splice. And then the other one is Western Union, which is something like a straight connection of the wire, something like this. Okay, so three types of splicers. Okay, the first one is red tail, the second one is T splice, and the third one is Western Union. So this is some of the examples that has been done by my students in the previous semester. As you can see, I've given some tasks to my students to do that three types of wire splicing method. So this is the outcome. As you can see, some students can do it something like this, which looks nice, right? Okay. Some students can do it. Something like this is also acceptable. And as you can see, some students do it like this, which is, I don't know whether is she or he using the wire or not. Just some sort of rope, for example. And then this one, this is an example of the Western Union. It doesn't look like Western Union, just, I don't know, a typical shape. Okay, this is another student that submit this one, which is the T-splice, which is correctly done. All right, so after the splicing of the wire, okay, next is about wiring plan. All right, so for the wiring plan, basically we can divide it into two, which is a pictorial wiring plan. Okay, pictorial wiring diagram, which is something like this, which is more to the pictorial based display. Picture lah, like something like picture, which is we have the connectors here, we have switch, the picture of switch, then some other jumpers, right? So this is what we call as pictorial wiring diagram. So for the pictorial wiring diagram, it is something that is easy for us to understand. Even those with non-technical background also can understand this pictorial diagram of the wiring. And then the other one is something that is much more technical, which is, looks like this. This is what we call as functional wiring diagram. So this is the functional wiring diagram. As you can see, it is much more like something used in this wiring diagram. Basically, it is represented as a symbol, and then some. For example, this symbol, this representation shows the power cord. Okay, so from this power cord, it shows something like switch here, and then connected to the other component. Okay, so this is the PCB board. Then the other terminals. Okay, so the representation here is much more like abstract. Okay, it's not represent the actual picture, actual photo of the which is something like this is much more easier to understand. But this one is needs some sort of a technical background to understand this sort of drawing. So this is the functional wiring diagram. So the element of wiring diagram. So for the element of wiring diagram, basically it consists of three elements. Okay, so the first one is electronic component. So in this functional wiring diagram, as you can see, the first one is about the electronic component. How do we represent the electronic component in the functional wiring diagram? Basically, it is shown by using the shape like square, rectangular shape, or round shape, right? And then some letter number. Okay, as you can see here, some shape of the component, round shape, square shape, right? And then small round here that represents the component. And then some letter number. Letter number R3, D5 here, T1 here, okay, S1 is here, right? And then other than electronic component, it shows also the component terminals represented by small circle. So this small circle basically shows the component termination, okay? The component terminus, right? For example, as you can see, D5 is supposed to be something like diode component is supposed to be here, right? So this is the terminal for wiring of across the diode. And then wire or wiring lah. Okay. The third one is wire or wiring. That is represented by straight lines or right angle lines, which is this is the wire, the right angle. Okay, 90-degree angle. Okay, the straight lines and the right angle is there. Okay, so it has three components, basically electronic component, component terminals, the termination of the wire, and then also the wire itself or wiring. So that was about the element of wiring diagram. So this is the figure of a complete wiring diagram, which is the similar figure that you have seen in the previous slides. So basically in this drawing, as you can see, in this drawing, you can see the drawing start with placing some round or square or rectangular representation of each component, which is S1 is a rectangular shape, round shape of R3, right? Something like that. And then next small circle are drawn to indicate component terminals, which is this is the small circle that indicate the component terminals. And then once the component terminals are in, lines depicting wires are drawn. From this component terminal, we can draw the lines, which is at the right angle, and also the straight line in the right angle to the another point of the terminal, right? Another point of the wire. And then finally, the component identifiers, which is the label of the component, R3, D5, something like this one is S1, okay, that represents switch. And also in this drawing, also you should place some title blocks, borders, okay, the initials of the somebody who has approved this drawing. This drawing prepared by who, the title is here, which is wiring diagram, variable power supply. This is variable power supply wiring diagram. Okay. And then next is about final packaging. After the drawing, now we move on to the final packaging. So for the final packaging, it is similar to the wiring diagram as well. It's divided into two, which is the first final packaging is something like the pictorial one, and the other one is the functional final packaging. Okay, so for the pictorial assembly drawing or the pictorial final packaging, it is something like wiring, which is something that is easily to understand. Even school student also can understand because it is based on the pictorial. It is a picture, right? But for the functional assembly drawing, it is easier in terms of drawing. Okay, to prepare the drawing is easier because it's using the symbols and the lines, right? But to translate this drawing, it needs some expertise, like experienced person will be required to read the drawing, right? So basically, in terms of preparation of the functional drawing, it's easier, but in terms of translating into something that we give to the person must be experienced person to read this drawing. But for the pictorial or pictorial assembly drawing, it is much more easier in terms of reading that drawing, but in terms of preparing that drawing is much more difficult. An example of the figure that shows the pictorial assembly drawings. As you can see, clearly we can see some SW4 is something like switch. Right, this is another switch. The screw image is screw, right? And then the other image like Bnc connectors here. Okay, Bnc connectors is something like audio connectors, right? Bnc connectors, when you have a look at the back of the monitor, for example, or the TV set, behind that TV set, basically you will see the Bnc connectors, which is we use it to connect the antenna. Okay, we connect the antenna using Bnc connectors. So there are some other components like washers, spacers, okay, screws, so on, nuts, and so on. So this is another pictorial assembly drawings. As you can see, normally we see this when we purchase, we buy some furnitures from IKEA, for example. It shows something like this, which is easier to read, easier to understand, right? For the assembly process of this furniture, for example. So this is another example, but this one is a functional assembly drawing, which is, as you can see, this is the image of variable power supply just now we have discussed. So as you can see, this is not more to the pictorial, but some things like abstract, okay? So it labels some parts, which is the components. It's labeled in such a way like something like numbering based labeling for the components. Okay, so next is about the final packaging drawing. So before that, it was about assembly drawing. So this is about final packaging drawing, which is final packaging. It is something like how does our project, or how does our circuit of our project, a project looks like from outside, right? So that is about final packaging drawing. So for the final packaging drawing, it is something like this. We have learned this from the topic 2, which is about drawing. So we have discussed about the final packaging drawing. So this is basically the final packaging drawing example, as you can see here. The components has a balloon part number. As you can see, the component has a balloon part number. All of these balloon part number are the components. Okay, so there are some component which has, for example, this one, 4, 5, 6, and 7. Okay, what does it means by this single component, but it has different parts? Okay, part 4, part 5, 6, and 7. So basically, this example shows, for example, if I can read this 4, 5, 6, 7 component is basically the screw with nuts, washer, and spacer. Okay, of course, when we do the final packaging, when we use screw, some things that is also come with that screw, like washer, okay, like spacer, right, like nuts, okay. So it is labeled like this. So 4 is screw, 5 is nuts, 6 is something like spacer, right? And some other component is labeled in one single number. Some other components is labeled with the number which is in the straight number like this. So this is the list of the components. It has some, this is the part list, basically represented in terms of table, which is something like this. So this is more to the mechanical one, the part list, which is basically the final packaging is much more to the mechanical work. It's not the electrical based work. So basically in mechanical work, something like this, when we do the final packaging or assembly, basically we will also prepare this sort of part list, which is very similar to the electrical component that we have done in the PCB. So this one shows the part list with indenture, part description, comments, part number, item number, right? The indenture is basically a way of indicating what smaller items are part of a larger item or sub-assembly. For example, the indentation for this one, variable power supply, is the big component, okay? Chassis is much more smaller. PC board assembly is much more smaller component than chassis. Smaller components like screw, nuts, washer, spacer is marked in the indenture in the most right column. Okay, the right column. Okay. So this is the smallest component. The left column, which is the most left column, shows the biggest component. Like variable power supply is the only one of the only component, which is where is it? This is the image of variable power supply. Okay, the whole image. This one is the variable power supply. That is why the indentation here is marked at the left column of the indentation. Okay, so basically we have finished all of the part all of the sections are covered in the prototyping 2 topic 5. Okay, so we have finished this part. So I will be moving to next slide, which is the final slide, testing and troubleshooting slides that belongs to topic 6. All right, so I will be discussing that one. Maybe we will have a break about 2 or 3 minutes before we start that session. So basically, I'm going to stop this recording first because for that recording, I will be starting another recording. So stop this.